Earlier today, Sally cut her finger but thankfully now she's okay, and the bleeding has completely stopped. This gratitude is due to a physiological process called hemostasis. Hemostasis is a three-step process resulting in a series of actions that constitute to the formation of blood clotting. When Sally first cut her finger, she damaged the endothelial cells of her blood vessel, causing her body to send a message that causes her blood vessel to constrict. This process is known as vasoconstriction and is the first step in our hemostasis formula. Once the blood vessel has been constricted, a message is now sent to format a plug, attempting to stop this bleed altogether. This is the next step in our hemostasis process and is known as the platelet plug formation. In our blood, we have a few things. We have red blood cells, white blood cells, proteins, and these structures called platelets. When there is injury, platelets form together to adhere to the site of injury. This process is known as platelet adhesion. Once glued to Sally's blood vessel wall, the platelets begin changing shape, releasing chemicals that call upon further platelets to come towards the damaged area. Now Sally's platelets are said to be activated. Once activated, the presence of platelets draw upon additional platelets, forming a loose plug. This step is known as platelet aggregation and is the main goal of primary hemostasis. However, this plug won't stop Sally's finger bleeding for long, and thus we need another substance for the formation of a clot. This is where secondary hemostasis occurs, and we see fibrin, which is an insoluble protein, form a meshwork around our loosely arranged platelets, finally clotting Sally's blood. But first, we need to talk about where fibrin came from. In Sally's blood is a group of proteins called coagulation factors, and these are usually produced by the liver. When activated, these proteins set off a series of reactions called the coagulation cascade. There are two ways Sally's body can trigger the coagulation cascade. First is through a tissue factor known as collagen. Collagen is a subendothelial protein, meaning it would usually stay beneath the surface of Sally's blood vessel. However, when she cut herself, collagen became exposed, triggering the activation of one of her coagulating proteins. When one protein is activated, so is another, resulting in a waterfall-like cascade that produces the tissue factor thromboplastin. This series of events is known as the extrinsic pathway of the coagulation cascade. When thromboplastin gets released into the blood, it activates its own set of coagulation factors, forming what we know as the extrinsic pathway of the coagulation cascade. This pathway then leads to the tissue factor thrombin. Both two pathways link up to what is known as the common pathway, and it is here, at the end of our common pathway, that we see thrombin turn the soluble plasma protein fibrinogen into long, sticky threads of insoluble fibrin. So now we have our sturdy plug with the fibrin mesh that we got through coagulation. However, too much coagulation activity permits the clot to grow much larger than it should. This could be problematic as too large of a blood clot could restrict our flow of blood, resulting in a loss of oxygen. Luckily, we have two groups of the body's own naturally produced chemicals which help limit the size of a clot. The first group is known as coagulation inhibitors. When this group interferes with the reactions among clotting factors, fibrin is blocked, and no new fibrin strands are able to hold additional cells to the clot, keeping clot growth to a minimum. The other way we see blood clots controlled is through fibrinolysis. Instead of blocking fibrin strands and stopping a clot growth like we see coagulation inhibitors do, fibrinolysis occurs as plasminogen activators, triggering the destruction of fibrin strands that hold the clot together. It's these second group of chemicals that are actually able to dissolve Sally's blood clot once her blood vessel has completely healed. Without it, those coagulation factors wouldn't be able to hold the plug, meaning Sally would experience hemorrhage, and if severe enough, she could potentially face death.